So in this section, what we're going to do is look at how to solve equations. First of all, let's go ahead and look at what the definitions that are needed to understand how to do this. So first of all, an equation is a mathematical statement that shows an algebraic expression on each side of an equal sign. Then we have what's called a linear equation. Now, a linear equation in one variable, we're going to learn about linear equations in two variables soon. But a linear equation in one variable is simply an equation that can be written in the form ax equals to b, where a and b are constants and a is not equal to 0. When a number is substituted into an equation that makes the statement true, that's what we call a solution to the equation. So if I was to substitute a value and it comes out to the identity, like 4 equals to 4 or 5 equals to 5, then we say that variable that we had or used is the solution. And to solve an equation simply means to isolate the variable on one side of the equation so that you can find the solution. All right, so let's go ahead and do that. We're going to go ahead and utilize all what we just learned to solve equations. Now here's the basic gist between an expression and an equation. An expression just shows you the terms together that are added or subtracted, whereas the equation, as we saw in the definition, is where we have an expression equal to another expression. And remember, in its generic form, an expression can also have a constant, or just like 5 as we see there. All right, so let's go ahead and try to do some of this solving by looking at some of the equivalent equations. So because of what we have, the addition property of equality, we can actually use this to solve equations. So I'm just going to turn on the pen. And so the addition property of equality says if I have two equations, such as a equals to b, and I add c on the left side to a, then I must do the same to the other side and add c over there. It's the same as subtraction. If I have a equals to b, I can use the subtraction property of equality, and if I subtract c on the left side of the equation from a, then what I do to one side of the equation, I must do to the other. It's the same with multiplication. If I have a equals b where c is not equal to 0, and I multiply c on the left side, I must multiply c on the right side, and vice versa. If I start on the right side, I must do the same to the other side. They are equal, and so that's what we call the addition, subtraction, and multiplication property of equality. And similarly, if I divide either side by a variable or a number, what I do to one side, I must do to the other. All right, so let's go ahead and try that. You can see that in the book. Now, the way that we're going to go about doing it is a little rule that we have to follow. Now, remember, we learned about the order of operations. And with the order of operations, we saw how we must work and evaluate an expression. But now that we're solving for an equation, we're working backwards. We're doing the opposite thing. And because we're doing the opposite thing, we will go in the opposite direction. So instead of working our way from the strongest operation down, we could say the strongest was the parentheses and grouping, exponents, etc. We're going to start from the opposite way back up. And we're going to start with the weaker operations when we do the properties of equality. All right, so instead of saying addition and subtraction last, we do the addition or subtraction first. And then also we're going to do the opposite operations to undo it. Remember, we're going to isolate the variable. So here's example 1. It says solving an equation with a variable on one side. Right? We're using the same examples from the textbook, but a little bit different. So you can always look back over the examples in your text. All right, so we have 3/5 of x plus 7 equals to 19. Now most students, they don't know where to start. So if we use the order of operations backwards, we know exactly where to start. We are starting with the weakest operation, addition or subtraction. We don't have to worry about the left to right stuff right now, so we could just erase that part. All right, so if I start with a weaker operation, that's my addition. And so if I start with the addition, then the opposite operation that I'm going to use to undo everything is subtraction. But remember what we learned with the principles of equality. If I subtract on one side, I have to subtract on the other. And because I'm trying to isolate the x, if you remember, we will subtract 7. Now that allows me to cancel on the left side. But remember, what I do to one side of the equation, I must do to the other. So I subtract 7 there. So that means I'm left with 3/5 x equals to 19 subtract 7, which is going to be 12. Now we have another equation such as ax equals to b, and remember we can isolate our variable. So we look at what's there. We have a fraction being multiplied by x. So I want to get the x by itself, and I'm going to start with the weakest operation. So I have a multiplication there. Now I can either divide, that's the opposite operation of multiplication. I could divide by 3/5, or I can do what we learned in the previous section. Instead of dividing, I can actually multiply by its reciprocal. And so if I do that, that's the same step as dividing. If you remember back in pre-algebra, we could do the reciprocal. We can multiply a fraction by its reciprocal, which is the same thing as dividing a fraction by itself. And what I do to one side of the equation, as we just learned, we must do to the other. So I'm going to multiply that by 5/3 as well. Now this balances the equation, kind of like a seesaw. And so once I do that, my 3's will cancel. Remember, you can cancel diagonally. And the 5's cancel, and I'm left with just x. Over here, hopefully you remember cross cancellation. You can either say 12 times 50 is 60 and then divide it by 3, or you can cross cancel, noticing that these have common factors. So 12 divided by 3 is simply 4, and you still have that 5 there, and that's a multiplication there. So 4 times 5 is going to give us 20, and that is our final answer. And if you want, you can substitute to check. You can substitute back into this equation and to see if it's correct. So you could say 3/5 times 20 plus 7, and you want to see, does it equal 19, right? So you can cross cancel again. That 20 divided by 5 is 4, and 4 times 3 is 12, and 12 plus 7 does yield 19. And because that yields the identity, we know that we're correct even before somebody grades us. All right, so let's move on to another example. Here we're going to do it when we have a variable on both sides. We're still going to use this concept here. Now sometimes you can simplify before you start, but we're going to go ahead and start with the weaker operation. Now remember, these are terms, and we want to treat them as like one entity. So we want to get our x's on one side. We want to collect our like terms, basically. We want our x's on one side and the numbers on the other side. Because the whole purpose, remember, as we just learned, is to isolate the x. And so in order to isolate that x, let's get our x's together. Now the easiest thing to do if you want to stay away from the negative signs is to always move the smaller x. So instead of moving the 9x to the left side, we're going to move the 6x to the right side. And that way we keep our x values positive. Alright, so we remember we do the opposite operation. So since that's a positive 6x, we're going to use a negative 6x, which causes us to cancel out. Right, that's the identity and the inverse property we learned before. And what we do to one side of the equation, as we just learned with the equalities, we do to the other. And we always make sure we collect like terms, so we subtract it from the 9x. That gives us 13 on the left side, and 9x subtract 3x, remember, is 3x. Sorry, 9x subtract 6x is 3x, and we have subtract 8 that we bring down. We want the numbers on one side, so we do the opposite operation of the number we want to move. The opposite of negative is positive. We do it with the same number, and what you do to one side of the equation, do to the other. All right, the 8's will cancel out, and 13 plus 8 is going to give us 21, and so we have 21 equals to 3x. There's only one operation here, that's the multiplication division. 3x is 3 times x. Remember, we do the opposite operation, which is division, the same number we want to move, and what we do to one side, which is division, by 3, we do to the other. And so the 3's cancel, 21 divided by 3 is 7, and you get x. And once again, you could take that x equals 7 and substitute it back in there to see if you get the correct answer. And so 6 times 7 plus 13, will that equal to 9 times 7, subtract 8? Well, 6 times 7 is 42 plus 13, and 9 times 7, 9 times 7 is 63, I believe. And then we have 42 plus 13. That's going to give us 55. And 63 subtract 8 will also give us 55. We get the identity, so that's correct. All right, so let's move on to the next example. And I'm just going to clear this. And we have example 3 here. Now, in this one, we're going to utilize the distributive property first. Now, you technically could use this rule here, but it's always easier when you have the grouping to just simplify first and then follow the rest of the steps. That is the best and easiest way to go about any question where the distributive property can be utilized. All right, so let's go ahead and distribute in. We have 2 times a half x and 2 times 5. Now remember, half of 2, which is multiplication, is just 1, so you're left with x, and 2 times 5 gives us 10. Over here, remember, that's a negative, so you want to multiply the negative in there. Two negatives are equal to a positive when you multiply, so you get positive 4x. And remember, negative times a negative is also a positive there, so negative 4 times negative 3 is 12, and you have subtract 5x on that side. We can collect the like terms on the right side of the equation first. So let's work with those x's. We have x plus 10 on the left side. We can add the 4x with the negative 5x, and that's going to leave us with negative x plus 12. Remember, we want all the x's on one side of the equation, so we're going to add x. We want to get rid of the negative. You could leave the negative there, but I like to get rid of the negative, so since I have a negative x, I'm going to bring it on the other side of the equation by doing the opposite operation, the same number of variable, and what I do to one side of the equation, do to the other. Alright, so these x's cancel. X plus x is 2x. We still have that plus 10 there, equals to 12. Remember, we want to isolate the variable, so we want to bring that 10 over by doing the opposite operation that belongs to the 10, which is subtraction with the same number. What you do to one side of the equation, that's the equality property, you do to the other. These 10's will cancel out, and you're left with 2x is equal to 2. 12 subtract 10 is 2, and you can, most times you could just see that answer, but let's follow the steps. 2 and x, that's multiplication, so you will divide to get rid of the 2. And what you do to one side, you do to the other. So those 2's cancel, and you're left with x equals to 1. Alright, and you can substitute that in there to solve to see what you would get, and you see that that answer will equal once you do your check. Alright, let's do our last one. I believe it's one more, and we're just going to do that once I erase this. Okay, so with this one, what you can do, you can either try to make all the fractions the same, have the same denominator, but that will take a lot of work. We're still going to follow this rule here of starting with the weaker operation, but what we're going to add there is the LCM or LCD. Sometimes people call it the LCD for when you're dealing with fractions, but it's basically the lowest common multiple or the lowest common denominator. So what you're going to do, you're going to find the lowest common multiple of all the denominators. And now remember, any number can be written as a fraction of 1. So you have 4, 3, 6, and 1, and you want to find the lowest common multiple between the two. Now, you should know how to do this already, but you remember you can find the multiples by doing the multiples of 4, the multiples of 3, etc., the multiples of 6, and then see what's in common. Now that's the long way. If you do it the short way, that's just doing it most times in your head. Hopefully you just know that 12 would be the lowest common multiple. So our LCM here is 12. Now what you would do, you see this in your textbook, so you can always get the steps. You're going to multiply everything by 12. And that will allow for the denominators to cancel. So we can put it all in like a giant parentheses. We have a fourth x plus a third on the left side. We're going to times it by the LCM. And on the right side, we'll do the same. Times it by the LCM. And what this does, it eliminates the fractions. So 12 times a fourth is the same as saying 12 divided by 4, which gives you 3x. 12 times a third is the same as saying 12 divided by 3, which gives you 4. And you see that? We have eliminated the fraction. You could do that whenever you have an equation and you're trying to eliminate the fractions. All right, 12 times a 6 is the same as saying 12 divided by 6, which is going to give you 2x, and then you multiply in, right? Remember, we're multiplying into each one. 12 times -1 gives you -12. All right, so now we're dealing with the equation we just did when you have a variable on either side. You remember you want to get the variables on one side and the numbers on the other, and it's easier to move the smaller x value. And you're basically still following this concept here. I might not always say it, but that's what I'm doing. So you start with the weaker operations. In terms of operations, there's only addition and subtraction. So removing the 2x first by doing the opposite operation with the same term, and what you do to one side of the equation, do to the other. So these will cancel out, and on the left side, you're going to have 3x subtract 2x, which will give just x. You bring down the 4, and you have plus 4 equals to -12. Now you can solve by just doing the continuation of the steps. You will subtract 4 to get the x by itself, and what you do to one side, you do to the other. The 4's will cancel out, and you're left with x equals to -12 subtract 4. And if you remember with integers, you can always draw a number line to assist you. Or you could use even the concept of money. You can say I owe someone $12 and I owe someone else 14. How much will I owe them all together? And so you get x equals to -16. All right, so that's how you would do example 4. Please tell me I actually recorded.